Greetings again. It's your favorite professor, Dr. T. So, on to the next topic, function tables with two-step rules. So, just to break down a little bit of what you see in front of you. So, we have a table here, and we have variables X and Y. I'm just putting a little check mark there. I'm not going to leave it there, though. Kind of gets in the way. And then we have a dependent variable y. So what this is saying is that y depends on what number you substitute in for x, the letter x. So if you see here, we have some x values, and we're going to take all of those x values and substitute them in for the letter x, and then we should get a y value, and then we can fill in the table. Okay? So before I even do that, I want to show you a powerful tool using a calculator, an online free graphing calculator called Desmos. So Desmos has a very powerful tool. Now, you can also log in exactly what we have in our ALEKS window. I believe it was y equals 4 plus 3x. Let me just check one more time. 4 plus 3x. You see that there is a line, and the function that you just observed in ALEKS is here represented by a line. So what does that mean? In order to draw a line, we need coordinates. There's many coordinates on this line. But for our purposes, we actually need to know what value we get so that we can graph this line if we substitute the numbers in for x in this actual function. So I'm pretty sure that one of those values was 1. I think the next one, I need to press, I'm gonna just move my face out the way. I think it was 2, and then I think it was 8, and I think it was 10. And then all of the other values I can just delete just so that they're not confusing. Okay? So right there, you can see exactly what the results are using Desmos. Now, we're talking about all of the points that are just positive on the right side of this coordinate plane. And if I click in the box, I see 1, 7. I see 2, 10. And 8, 28 is really high up there. But if I wanted to see them, I could see them as well. Now, just in case you may forget what those coordinates are, you can actually type them here. 1, 7. And then you can label your graph, and then it stays there. And you can do that for all the coordinates. So for instance, if I wanted to do 2, Let's say I wanted to do 2 comma 10 to label it. Okay, and then you can see what's happening here. So try it, pause this video and try it yourself. And then we'll go back to the actual problem. So doing this algebraically, can do each one by hand. So y equals 4 plus 3 multiplied by 1. What is that equal to? 4 plus 3, which is 7. 4 plus 3 times 2, and that equals 10. Do you remember those coordinates on the graph? And then y equals 4 plus 3 times 8, and that equals 28. And then y equals 4 plus 3 times 10, which is 34. And then you can substitute all of these values in these boxes, and you have your answer. Okay. And then this is just the work shown when I click the explanation. Okay, so, and I like how they have the colors. It stands out. So let's go to the next one. And I want you to try to do the same thing using decimals. So you can pause this video and you can do the same thing with decimals. I am just going to do them all by hand. Y equals 1 plus 2 times 1, which is equal to 3. Y equals 1 plus 2 times 2, which is equal to 5. Y equals 1 plus 2 times 3, which is equal to 7. And then y equals 1 plus 2 times 4, which is equal to 9. Now, one thing I want you to notice, what is the change from here to here, and from here to here, and from here to here? So what is 5 minus 3? It's 2. What is 7 minus 5? It's 2. What is 9 minus 7? It's 2. The slope of this function is 2. Whatever number is in front of x is your slope. Okay? I can say one more thing about the x and y values on a graph. So if I make x equal to 0, what will my y value be? So y equals 1 plus 2 times 0. My y value will be 1. Okay, so this is called the y-intercept. And vice versa, if I wanted to make y equals 0 in this function, I would say 0 equals 1 plus 2x. I would subtract 1 from both sides, get negative 1 equals 2x. And then I would divide by 2. And my x value is equal to negative 1/2. Okay, and I can actually prove that to you using the decimals calculator. So my function is y equals 1 plus 2x. And you can always turn these off, so you can leave them there as a reference. Let me unlabel those. So y equals 1 plus 2x. And let's turn that off. Okay, so if you click this little settings button and you click the table, you can see here some of the values. So where I made x 0, y is 1, and that is what I got when I substituted in x being 0. Okay. If I make y equal to 0, what did I get when I made y equal to 0? I got -1/2. So x is equal to -1/2, and I'll write this just to keep it proper. So when x is 0, y ended up being 1. And when y was 0, x ended up being 1/2, where x is equal to -1/2. So if we zoom in a little bit, we can see there's -0.5. And if I'm not sure, I can type in negative point. Sometimes people like to be very proper about their points. So 0.5, comma, 0. And there you go. So hopefully Desmos helps you visualize what's actually going on with a table of values. Thank you for watching. See you next time.